Okay, so moving on with session 6, we're now in a position to calculate the error function using the numerical integration function trap that we've created in the previous screencast. Okay, so if we go to MATLAB, if you remember, we can call our function trap to integrate our e to the minus x squared between certain limits. Now the error function is defined by 2 over the square root of pi times by this integral. Okay, so if we, and actually MATLAB has an error function built in. So the error function is actually called earth error function. If I type help on earth, that gives me some information. Okay, so that's the definition of earth x. It's 2 over the square root of pi times the integral from 0 to x of e to the minus t squared dt. Okay, so I can calculate using my numerical integration routine the integral between 0 and x of this function, and that function is called Gaussian. So if I now hit the up arrow to get a previous time I called the function, I need to make the lower limit 0 and the upper limit whatever I'm trying to calculate the error function. Let's say the upper limit is 1. Using width of 0.04, that will give me the area under the curve. I just need to then multiply that by 2 divided by the square root of pi, and that should give me the error function. Okay, so if I type here should give me error function. Check that by comparing that with the error function directly. So there we've evaluated the error function of 1, integral between 0 and 1. So that should be equal to earth 1. Okay. We see here it's nearly equal to, we've got 0.8426 here and 0.8427 there. So what we need to do to get our function accurate to 4 decimal places is we can try to use a finer resolution or a thinner trapezium width. So let's call this again, but now give it a trapezium width of 0.02. Okay. That now gives me V1 is equal to 0.8427, the same as V2, which is the exact value. Okay. There are more decimal places here, but we're just looking at 4 decimal places.